Dear all, first of all, thank you for joining and welcome to today's webinar on software-defined vehicles, the new paradigm in the automotive industry. I'm Virginie Toussaint and I will act as the moderator for today's session. In today's webinar, we will share with you our return of experience and knowledge, exchanges of the challenges in terms of software becoming one of the major drivers for innovations in the mobility industry, especially linked to the megatrends of connected, autonomous, shared, and electric mobility, which are mutually reinforcing developments in the automotive industry. Today, we will explore the impact of software on the way the industry engineers, manufactures, and delivers the vehicles and mobility services of tomorrow. We will concentrate at looking at this paradigm shift as an opportunity for the industry. Our speakers today are Peter Fintl, Director of Technology and Innovation at Altran, part of Capgemini. Peter is an electronics engineer and business economist who has been in the automotive industry for more than 20 years. Peter currently works as Director of Technology and Innovation and has a focus on automotive driving and sustainable mobility. Rodrigo Maia, Chief Technology Officer at Altran of Capgemini in Portugal. As Senior Executive with more than 20 years of experience, Rodrigo has been responsible over the last 5 years to build a business unit on intelligent systems focused on software development for embedded systems. Before we begin, I would like to cover a few important points. If you have any questions during the webinar, you can send your questions in the Q&A console and submit them for our speakers. At the end of the webinar, we will ask you for your feedback. It will take only a few minutes and it will be extremely helpful. The webinar recording and presentation will be made available on our website. With that, I invite Peter and Rodrigo to start the session.
Virginie, thank you very much for the kind introduction. Yeah, my name is Peter Fintl, and today with my friend Rodrigo, we will take you on a journey through the software-defined vehicle. Let me explain you a little bit which places we will visit this afternoon. So we want to see why is the concept of a software-defined vehicle important? How is software eating not only the automotive industry, but also other industries? How will it impact the architecture of the vehicles, right, and overcome today's limitations? What is shifting in the vehicle also from a user perspective, and that will guide us through the impact of software in the automotive ecosystem, as well as to answer the question, what is the future position of OEMs, of tiers, of suppliers in the automotive ecosystem of the future. Let's start right away. So why is the software-defined vehicle a real thing? The question is, but aren't our current cars already full of software? You know, I think you understand that each time you start up your car, the navigation system boots up, it takes forever, and sometimes it even produces error messages. So that's an indication that software is already a big part of the vehicle. So we've tried to answer what is changing and what is happening now. Rodrigo, can you help us out here?
Thank you, Peter. Thank you very much for the question. And let's look at what is software today. So today, software defines practically everything. Okay, from radio to network functionalities, we can find functionalities driven by software in airplanes, cars, trains, different kinds of industries. Well, we can look at several examples of this software-defined everything. Over the past decades, and if we look at the course of evolution in technology, we have seen a range of functions that were pure mechanical or electrical becoming digital. But the initial change was from analog into a digital world. Now, what we see is that the software is defining the functionality and interacting not only with the physical system that is responsible by, but also interacting as well with other logical remote systems. The major shift is that the hardware no longer drives the function. It has become an element of the software-defined functionality. But in the case of the automotive industry, what are the key drivers that are making this change happen, Peter?
Yeah, clear. The automotive megatrends, they are here, right? And they are here to stay. Let's start right away with the drive for electric. Climate change is a thing, and many major countries in the world, they have committed to become carbon neutral in the next decade. And a part of that is a ban of internal combustion engine vehicles as early as 2030 onwards in many countries. And lately, even General Motors has announced to go fully electric. So this change is found and it is happening right now. If we look at shared mobility, this is not only a potential recipe to fight traffic jams and meet mobility demands of growing cities, it is also a recipe for growing revenues and profits, right? So having proper brokering platforms for those mobility services, this is key. When we come to autonomous mobility, driving automation, it will bring us safety to the roads. Currently, we lose every year about 1.3 million people in traffic-related fatalities, and this needs to stop. But driving automation will also boost our productivity and make driving time more usable. So this potential productivity gain is a benefit for the whole society. And when we come to connectivity, having connected and networked vehicles, we can increase convenience, safety, and optimize traffic flow and increase economy. And all those four trends, they have one thing in common. They are powered by software. So which key software technologies are enabling those megatrends for automotive? Rodrigo, would you like to explain?
Yes, Peter. So from the technology side, I would highlight the immersive connectivity that now vehicles possess. They can connect with practically everything from remote cloud services to other systems or other cars. There is a rapid evolution in the processing power and in virtualization, which hugely improve the real-time capabilities inside an automotive electronic system. We have the cloud's infrastructures combined with artificial intelligence, machine learning, which are powering up the emergency of intelligence inside the vehicle. And all of this together potentiates a set of new challenges in the safety side, okay, driven by the fact that we will have more functions inside the car which can potentially harm people or other users of the road. And we will have, by the immersive connectivity, by the different ways that the vehicle will interact with others, we have new challenges in the security side by breaches that can be used in order to harm other people. So that being said, how is the automotive industry looking at to this trend and to these changes, Peter?
Yep, absolutely. If we look at statements from industry leaders, like here from Mr. Dies, the chairman of the Volkswagen Group, which said software will account for 90% of future innovations in the car. Yeah? So I think to take that as an example, we see that the role of software as the core element of future innovation, it has been broadly understood. Right? But the vehicle software, it is already a core part of automobiles today. Without software, no internal combustion engine is turning, and no car door is opening, no navigation system is guiding the way. So the question is the software-defined vehicle already here? And is the vehicle software only compromised of the vehicle itself? Rodrigo, maybe we check it out a little bit.
To answer to your question, we need to look at the definition of a software-defined vehicle. Software-defined vehicle is a term that describes a vehicle whose features and functions are primarily enabled through software. This is a result of an ongoing transformation of the automobile from a product which is mainly hardware-based to a software-centric device on wheels. If we look to premium vehicles today, they have up to 150 million lines of code to run their systems. They have more than 100 ECUs composing the electronic skeleton of the car. And they have a growing array of sensors that provides them the feeling, the sensing capabilities, ranging from cameras to radars to lidars to GPS to IMUs, you name it, you will find it on a car today. And if we look to the mass market vehicles, they are keeping up the pace they are picking up the pace really fast. We are seeing more and more features and functionalities being put as well in the mass market. So as Peter said, the four powerful trends, connectivity, automation, shared mobility, and electrification, are reshaping the customer expectations, and manufacturers are increasingly looking for more and more software as a way to address all of them. But Peter, should we say that this is limited to the vehicle itself?
Exactly. Yeah, I think we should come back a little bit to that question we had before. You know, what happens to those domain silos we had, right? So I think we can conclude a full software-defined vehicle, yeah, opposite today, will have its function distributed between a range of systems in and out of the car. We will see the domains in car, edge, cloud, and mobile, right? And the borders between those domains, they will become much more fluid in the future. Right? So inside the car, this will be defined by a feature-rich infotainment system, automated driving function, but they will be networked to edge computing facilities, right? Who provide connectivity to other vehicles, to infrastructure, or provide insight, real-time insight into traffic situation. The cloud will become a natural part of the vehicle. We will be always on, right, and access through this cloud functionality, other services, other data streams, and access to large data pools of the fleet. And last but not least, the mobile devices of the users, they will become a much more integrated part of the future vehicle, not only to unlock the doors, right, but to make the border between the mobile device of the user and the vehicle much more seamless. And that brings us to the next part. So let's look at how the software is changing the face of the automotive industry as we know it. Rodrigo, you remember the old times, how easy it was when automobiles were defined by horsepower, number of cylinders, and top speed. Yeah, when simply adding a piece of chrome was already enough to call it a new model, right? That all that sounds like from a different era, but in reality, it's not so long ago. Rodrigo, where are we going now and in the years to come? So what has changed in the overall consumer sentiment?
Things have changed indeed quite a lot over the past few years. Who would have ever thought that a vehicle buying decisions would be influenced by the fact that our mobile phone connects better to this car or to that car, or that we could have an adaptive message seat as an appealing argument to select a car. So what we see today is that the software is the king. In this world, the software defines the customer experience and is the responsible for creating the differentiator. The cars of the past were characterized by handling, horsepower, or styling. But for the new ones, we are definitely looking at cars that are connected, personalized, and enriched with functionality. The car is becoming more digital and we are interacting with it in multiple ways, not only by the steering wheels or the pedals like we used to do. We are interacting with it from our mobile phone, from our laptop at home, and not just the driver anymore. Every user, every passenger of the car will interact with it, making it part of a common digital ecosystem.
Mhm. Right, Rodrigo. Yeah, this is true. Yeah, I think the audience will concur that we are totally influenced by smartphones, by touch interfaces, by the aesthetics of Apple and the other providers of high-end smartphones. Right, by the concepts of gamification, of measure everything, and also of quantifying everything and having immediate feedback and insights. And I think those are huge drivers for change in our industry. That brings us to the next point. Yeah, so we see the demands are changing, and the question is, how does all that influence the architecture, the technology of the vehicle? What was possible in the past, and what is needed for the future? Rodrigo.
Yeah, Peter. Indeed, we have come a long way. Okay, as we see in the picture, the evolution of the electronic landscape inside the vehicle has shifted dramatically over the last 70 years. From the electronic revolution in the 80s, where things started to speed up, and where we have started seeing engine control units or comfort areas inside the vehicle, to the infotainment and the safety features in the 2000s. Okay, to the driving assistance systems, the powerful driving assistance systems that we have now since the 2010s. A lot have changed, but a lot more is to come. Right, Peter?
Right, absolutely. And if you look at the 2020 picture, you see how much stuff is crammed in the vehicle. And you know what? It seems we have to fight space constraints. The vehicle is getting more heavy. We have a cable complexity. And you know what? That definitely looks like problems the aerospace industry had a couple of years ago. And they had to change the architecture of their airplanes, right? Yeah. So I think we see that new concepts are urgently needed. The question is, what can we do? And I do hope we will see that later in our discussion today. But before we deep dive into solutions, Rodrigo, can we shed some light on what is really shifting in the vehicle and what are users going to expect in the future?
Yes, let's look at the vehicle, and let's start by looking to what the eyes can catch. Okay, what are the OEMs moving into? Okay, looking to the recent announcement from Daimler of his new integrated hyperscreen, we are seeing a lot less knobs and handles. We are definitely seeing much more touch screen. We are seeing touchless functionalities like gesture recognition. We are seeing immersive displays experience, okay, where the screen becomes the dashboard, okay, and everything is visual on it. But apart from what the eyes can see, a lot is happening where the eyes don't reach. So what do you want to say to us about this, Peter?
Right, yeah. It said it's not only by replacing knobs by touch, yeah. It's having a new approach about functionality, delivering new experiences during the use phase, in short, making the car updatable and adaptable to the user. Right, like Tesla here, for example. So they have shown a few in the future about how features for comfort, like preconditioning, location-aware air suspension, or performance updates, like new software for the BMS that makes the battery last longer or give us a few more miles of range. Yeah? And also new services like the Tesla Show, watching Netflix while you're charging the car, how all that could be delivered over the air and could in the future open new revenue streams for the manufacturer, right? And also they have shown that car buyers, that they are willing and able to spend money for functions or for to add functions later on, like the famous autopilot or heated seats and so on. Yeah. And last but not least, they have also shown that via remote updates, you can bring some fun and brand commitment to your user community, with the famous Tesla Easter eggs and all that. So we've seen what's possible and where the trend is going. So the question is how to enable all that. So certainly we need a platform in the car that is powerful in terms of computing performance, right? So a supercomputer on wheel that we said before, but we also need an architecture that is updatable and where software covers all aspects of the vehicle, and a platform that is steadily connected to the mothership, right? So, and I think with those ingredients, this will reshape how we perceive mobility. Rodrigo, could you continue here a little bit more, explore more a little this direction?
Yes, and I believe that this concept of mobility is something that is going to dramatically change. We have seen with Tesla a glimpse of the future, but the cars, and looking at our picture on the slide, we can see changing their shape and the way that they are used. They are definitely going to become a third place, apart besides from our home or our offices, where we can relax or where we can become more productive. Definitely, they will let us use our time in a different way, moving it from time wasted to time well spent. But if this drives a change of the usage, it also drives a change on the expectation and brings a question to us. Are we, the automotive industry, still competing just with a small group of companies, okay? A small group of OEMs, okay, which disputed the mobility ecosystem, or these new technological trends, these huge business trends that we see, are they calling into the game other other players that want to dispute this field? Peter.
Right, Rodrigo. Yeah, I think this is an excellent question. Yeah. So, whom is the industry in the future really fighting against? Yeah. We mentioned the term intelligent vehicle before, right? And if we talk about the intelligent vehicle, it's all about adapting to drivers and passengers' needs to assist in their lives, right? And to make the third place, this new third place, a very livable one. But wait, isn't that also what the wave of digital assistants are promising, right? To become a seamless part of the user's lives. So I think we can say that in the future, the automotive industry also has to compete with the Siris, the Alexas, or the Google Assistants of this world. So the integration of the vehicle in the ecosystems of assistance, in the networks of the users' lives, as well as the use of data, that will be a future challenge, right? And this communication from the vehicle to the user does not stop in the simply immediate digital life, right? It also means that the vehicle needs to talk to other cars on the road, to traffic infrastructure, to weather services, to city infrastructure like parking lots, and even to the smart home of the user. And this vehicle to X communication and its integration with a proper usability, and this is a key here. So this will be a major keystone for the software defined vehicle of the future. So the question arises now, how is this software defined vehicle now finally impacting the automotive industry? Rodrigo, help us out here.
Yeah, so we can look at this from the perspective that the automotive industry was a hardware based industry, okay, where we could identify very long cycles of development. Okay, we have the example here of the iconic Golf with the 7 years lifespan between models. But we are now seeing a shift to, okay, we cannot launch a new version or a new model every 7 years. Okay, we have to be continuously upgrading and continuously updating what our users are getting from their day-to-day experience with our vehicles. So the pace of change needs to change. We need to change from the design to the engineering to the continuous update. Okay, and if we move to the next slide, we can see that on the traditional system, hardware system development, we are looking to waterfall approaches, okay, that now have to be mixed and combined with the standards in the software industry of agile and continuous development methodologies. Okay, and this drives a significant challenge for the industry to adapt to long development cycles, okay, to shorter development cycles, more iterations, more piloting, probably in the way that systems are built. But furthermore, the software evolution and the continuous evolution of software will expand the adaptability of the systems, okay, from what the hardware is designed in one stage until many years later, where it is still being updated with new functionalities driven by the software that it is running. And that is the shift that the industry needs to adapt by adopting not only the agile concepts for the development of the software, but the DevOps approach for the continuous deployment after the release of a certain system. Back to you.
Rodrigo, thank you. Yeah, Rodrigo, thank you. So I think we see the way we need to do things in the auto industry, it must change. Yeah? But maybe we should take this opportunity and also look now a little bit into the value chain. So where are the traditional players positioned and what is changing? I think it is understood that microchips are essential for today's vehicles. Yeah, and I would like to take this opportunity, this picture here, to illustrate a little bit how fast the world is changing. What you see here is the market share from 2018 for the traditional suppliers of semiconductors for the automotive industry, right? So just 2 years ago. Today, in the news, we are facing a crisis of chips, the so-called chip shortage, right? And OEMs were forced to hold their production. Overall, this year, we might lose a production of nearly 2 million vehicles that can't be a control of the assembly line due to the lack of supply for microchips. Yeah, what we're missing here is so-called system on a chips microcontrollers, right? So, and the providers of those, yeah, the core providers like NVIDIA, Qualcomm, they are not even on that list, what we see here, and the list is just 2 years old, right? Well, also, what we are not seeing on this list is the role of semiconductor manufacturing capacity, because the auto industry is here now in a role that they are need to compete not only for other automotive OEMs, but for example, for the system on a chips, they are competing with the smartphone, with the computer industry. So from a strategic point of view, the OEMs, they need to ensure a steady supply of technology. And in terms of microchips, that might need or might mean to bypass their existing supplier structure, the tier ones, directly go to chip providers and to their manufacturing partners to ensure access to those much needed resources. So this is just one aspect of the shift that we see in the ecosystem. But those are certainly not the only new entrants to the automotive world and the value chain. And I think we need to look what happens when chips and software comes together to a final product. Here, Rodrigo, I would like to hand over to you so that we ensure that we look a little bit about this situation.
Yeah, and we can look at the computing providers and the big tech giants, okay, and not only okay the disruption that Tesla has made, okay, acting as a tech company in a traditional OEM market, but looking to the other to the other traditional tech giants, okay, not only the Googles and Apples, but also the Chinese like the Baidu and Tencent. What will be their role on this? Will they be friends with the OEMs, or will they will play a role of the enemy, trying to dispute parts of the territory? What will be what can we think? What can we strategize about the role of the different ones in the industry? Okay, will they dispute the role of the OEM? Okay, becoming it themselves integrators, which seems to be the approach being followed by Apple. Okay, to become an integrator of their own car, their own vehicle, or will they be fighting to become a provider of a computational platform that is incorporated in the majority of the vehicles, which seems to be the approach of Google with the Android Auto, disputing the access to the user's data and maintaining their leadership into that domain, or they will want to become a service provider, and as a service provider, like they are in other domains. And here we can look at Amazon or Uber, where they will position themselves as mobility service providers, okay, providing the platform and charging the user by the usage of that platform. Okay, so how does this concerns the traditional OEMs? What should be their take on this new complex territory, Peter?
Absolutely, Rodrigo. You know, in the past, the OEM was the full owner of the value chain. He directed all aspects of the vehicle design, the engineering, the manufacturing, and also the sales and service process. Core technologies for many, many decades, like powertrain and engines, they have been traditionally under the full control of the OEMs. So certainly, the industry has striven for excellence and created a whole ecosystem of engineering partners, of component, as well as subsystem providers who contributed their work and technology towards a great final product. But as said, the OEMs, they were always in full control. But now today, we are not on a single value chain anymore. We have a lot of new sharks in the tank. And among those are the new entrants, like the e-mobility startups. Yeah, we see like the Teslas, the Neos of this world. We have the tech giants like Google, Amazon, Facebook, and also we have all the Chinese players that are coming in. They are often neglected in the West, but with Baidu, Tencent, Ali, and so on, you do see powerful and highly capable corporations who will come to the world market soon, right? And all those, they want to get into the mobility market. They are interested in data, in running platform businesses to provide mobility services. We also now see telco operators, right? They own the key to ubiquitous connectivity, and they see mobility as a profound way to get out of their commodity trap in just selling transport for IP packages, right? So they want to use their 5G technology, enable things like vehicle to X to create sustainable revenue streams for them in the future. And then we do have the silicon providers, as just mentioned before, because they deliver the core technology for future cars. Their chips, they power not only vehicles, they drive all kinds of intelligent machines across all industries. So the automotive OEMs, they really need to learn how to deal with those dominant players And this also includes to understand and master the complete semiconductor value chain from chip design to manufacturing. Again, to mention an example from Tesla, they designed their own computer core for their driving assistance systems. And at the time when they brought it to the market, it was way more powerful and energy efficient what you could buy off the shelf. And I think from this lesson, the automotive industry really need to look into what they integrate and put into their own controls. And speaking of integration and the landscape, I think, Rodrigo, we should take the opportunity and look a little bit of the future software landscape of the vehicle.
Yes. And we use this picture in order to illustrate the wide diversity of tech and software companies which are entering just in the autonomous vehicles landscape. Okay, and this represents a huge challenge to the OEMs. Okay, what to do, okay, and how to respond to this avalanche of new software frameworks and software initiatives that are impacting their ecosystem. In the past, we saw them taking the independent path. Okay, every OEM would own their own software stack, or it would share it with their tier ones. Later, we have seen the advent of standardization and the industry combining together to define software standards like AutoSAR or GenIVI in order to reduce the development efforts and to enable a better reutilization between the different elements. Nowadays, we are seeing, on one hand, the tech giants like Google and pushing forward computational platforms like Android Automotive, which provides all the functionalities for infotainment and vehicle control and chassis control of the vehicle to give them to and providing them to the OEMs to be used. We always know what is at the other end of the rope, where Google by this is stepping into the user data and making their revenue streams, which the OEMs have a hard time thinking that they will be taken out. But the price to pay to compete is that they need to develop their own ecosystems, create their own ecosystem of providers and users in order to make this effort to compete with the frameworks like Android Auto something relevant. Another example is what is happening on the driving assistance systems, okay, where initiatives like ROS and AutoWare, where new frameworks coming out of the open source community, okay, are providing freely and massively validated algorithms, modules, components for driving assistance functions inside the car. So the challenge here for the OEM is that they need to decide, should they compete, should they cooperate, or should they master the software framework that is at the core of their vehicles.
Thank you very much for that. So one question arises, yeah. So how do we do all that work in the industry?
Yeah, moving to the next slide. What we see is that all this technology evolution is driving a huge demand of incorporation of technology, of software inside the vehicle. And this places a huge challenge, okay? Because as we see on the graph, the demand for incorporation of technology is much higher than the productivity and the efficiency that the automotive industry and the automotive industry plus its suppliers can respond. So we need to find a way of dealing with this productivity issue, okay? Which we need to find ways to answer to these problems. And what are these problems, Peter? If we can move to the next slide.
Absolutely. I think what I understood from those things you described, right? I believe we're facing three problems. On one hand, it's the availability of skilled resources. Yeah, so it's a matter of manpower at the end, how to do that and how to make it happen. In the second aspect, it's a matter of processes, efficiency, and productivity, how to organize the way properly, and also how, to a certain aspect, how to find the proper organization for it. Last but not least, since there are a lot of new things, new technologies are coming into the industry, the question arises how to access or how to enable access to this new know-how and how to ensure a proper flow of innovation. And I think, Rodrigo, you have a few suggestions for a potential way out for us.
Yes, Peter. So what can we do about this? So I would try to divide the problem in 4 areas. So the first is automation. Okay, we need to develop the code and build code and test and validate the software inside the vehicle and outside of the vehicle by all means with a lot more automation. Okay, so model based computer engineering is by far one of the largest domain. The software has to be more modeled using models and use more code generation to develop the code. Okay, but at the same time we need to have more efficient way of testing and of performing validation, not only using the real vehicle, but more and more and more using digital twins, using synthetic environments, acquiring the data from the world, from the road with real cars, like we are doing with our managed services on the other data acquisition services, and put it into a cloud, build the synthetic world, and then use it to test the software functions of the vehicle. The second part is the efficiency. We need to change the processes of developing the software, more agile, more DevOps and DevSecOps approaches, but also benefit from the different time zones in using follow the sun approaches, where we can have teams in different continents developing on one part, testing on the other one, and validating on the other one, in making it the cycle of 24 hours more efficient for everyone. The third part is the reskilling and the upskilling. Okay, training academies like the AutoSAR Academy that we have made here in Portugal for our engineering center, or the others academy that we are developing now in Germany, or to build a co-creation of academies with the reskilling academies with the universities, to pick people that was from other areas of science into computer science and benefit from that. Last but not the least, the partnerships. And here I would give 2 examples. One is the joint ventures between OEMs and software companies that we are seeing. We have some examples from BMW and from other companies. And we have the partnerships. Okay, and on the partnerships, I would like to give our own example here in Portugal, where we have built a collaborative lab between Capgemini, Altran part of Capgemini, and 3 universities in order to create an applied research lab devoted to study and to accelerate technologies in order to enable them to enter into the production in cyber physical systems and in cybersecurity. So these are all proven concepts which we deal on our day-to-day life with the clients. Peter, back to you.
Mm. Right, Rodrigo, thank you. And as you mentioned, those are all tangible examples what we have in daily or problems we solve daily with our clients. Yeah, I want to take this opportunity to talk a little bit how all this work fits into our group's strategy called Intelligent Industry. You know, our group is convinced that the future is full of intelligent products and services, intelligent operations, and intelligent support and services. All that is supported by a seamless flow of data, by digital continuity across the value chain with all the tools, and last but not least, a digital convergence of key enabling technologies. So I think our strategy is fully aligned to what is happening now in the automotive industry. And there are three areas which I really wanted to point out. On one hand, what we can do is to create unique user journeys, right? To help our clients to make the new mobility experience a totally unique one that fits to the brand. Second, the group has a specialized know-how, not only in IT and engineering, but also in areas like artificial intelligence, or even in things like designing high-end radio frequency antenna for seamless 5G communication. And last but not least, and that's a very important part, we are a partner who could engineer at scale. With over 270,000 talented people, engineers, scientists, we are here to pull that off. And I think with this message, before we conclude, let's sum it up. What's our message for the audience, for the industry, Rodrigo?
Okay. Thank you, Peter. So, in order to conclude, I like to use the motto of Capgemini's Technovision of 2021, which is, in a world where change is so fast, where the technology is rapidly making the landscape evolve in so many different ways, but with so many external challenges, one needs to adapt, and one needs to be fast to adapt and not show any rigidity on the way that it is adapted. So be like water is the final message that I would like to pass to you. And thank you very much for your.
Thank you, Rodrigo. Thanks a lot, Peter, for the insights and for taking us through the software-defined vehicles new paradigm in the automotive industry. So I propose now to begin answering the questions submitted during today's presentation. As a reminder, you can still send questions through the Q&A console in your attendee control panel. We will try to answer as many questions as possible during our Q&A session. Our first question is this one. So you spoke of changes in the ecosystem. Peter, Rodrigo, do you see those changes also in the relationship between OEMs, technology partners, and consultants?
Hi, this is Pete. Certainly, because these profound changes, what we discussed before, they will redefine definitely the role of each person. So we see it from the OEMs. You know, in the past, they were relying on their tier suppliers to for innovation, for manufacturing capability, and now with this switch to the software-defined vehicle, definitely see a verticalization trend in the automotive industry. That means that without much ado, the tiers have a good chance to be marginalized in some of their core businesses. So all parties need to redefine their new roles. Yeah.
Peter, I would add up that companies such as Capgemini have a very important stake to play in this new context, because combining the excellent domain knowledge and historical domain knowledge from working physically with the traditionally automotive industry, like we have the track record in the past Altra, but also the conjunction with the data and with this new world of software-driven functionalities brought not only by Altran, but with a wide scope of Capgemini, we represent a very strong arm for the industry in supporting this change for the future.
I concur, Rodrigo, and I might add, I think what is missing at the moment and what is very much needed in the future is that role of the transformation partner, right? To get from the traditional models to the new dynamic models and processes of software companies. And I think to switch a large automotive company from this to that requires strong and experienced partners who both understand IT and engineering. Yeah, this I might add.
Thank you, Rodrigo. Thank you, Peter. We've got a second question. Agile development and DevOps seem pretty standard in the software industry. What is, according to you, the challenge in the automotive industry?
I would pick up on this. I would say that if we look to what is the traditional approach in an industrial world where we are producing physical goods, one needs to take into attention that we need to define and design very well before implementing it. Okay, so the traditional waterfall. In the software world, this approach has been much more iterative, okay, by the fact that we are building logical things, and the fact that we can build it with the agile methodologies, and then with the DevOps, once it's finalized, okay, keep continuously evolving it. One has this easiness given by the logical state of the software. Combining the two is a challenge. Okay, so we need to have hybrid approach, and for example, we are using safe methodologies to incorporate the software and the hardware in some of the phases. One needs to take care that the hardware itself needs to be more iterative. Okay, it cannot be all produced in a single stage. We need to identify what are the iteration steps that one can have, so that we can approach the two worlds, making it faster and making it more evolutive. Okay, which is definitely the new paradigm that we are bringing, is that we need to be considering that one vehicle will always be in evolution.
Thank you, Rodrigo. Indeed, we have lots of questions arriving in the panel. A third one could be interesting. What about the increase of bugs as in the software industry? Do you have a point of view on that?
Yeah, so one of the biggest challenges in the industry and is the issue of how to validate all the software that we are putting into a car, and more with the more autonomous functions that we are putting inside the car, and when we are putting functions which are no longer just pure entertainment or pure engine control or things like that. When we are putting functions which drive the car, which support the driving assistance, we are creating hazards that can result in faults, that can result in hazards, that can result in tragic incidents. So we need to validate and validate well. But to validate in today's world, it's not only looking at going with the car to the street and making all the tests. A lot needs to be done using digital twins, using synthetic worlds, using simulated data, or using simulated worlds driven by real data collected on the fields. It's one of the areas where we are developing a lot in Germany, with a fleet of cars that is equipped to collect the data and then support the OEMs, our clients, into building these data lakes of information that are used then to validate the software, not needing to go outside with the car and making the full test.
Mm. But this Rodrigo, I think all is valid, but it opens up another angle, and I'm not sure if we can discuss today. This is the increased need for cyber security, right? So we will have new angles on attack. This is clear, and we will also have new regulations in this field. Yeah. So some of you might know it, the famous UNECE Working Group 29 regulation. You know about the check for integrity of vehicle systems, right? Especially important after the introduction of over-the-air updates, which will come in inevitable. So there are a lot of new challenges ahead in implementing those functions and features. Yeah.
Yes, it's very good that you touched that point. So one of the initiatives that I have the pleasure to lead is the Vortex Collaborative Lab, where we are specialized in cyber physical systems and cybersecurity. And one of the key areas that we are addressing is exactly how to reduce and by design the way that cars and infrastructure are connected in a way that we can lower the threatened risk in those types of communications. Okay, vehicle to vehicle to vehicle, vehicle to infrastructure, vehicle to anything. Okay, reducing by design. Okay, at the communication level, how one can mitigate the threats in that domain.
Right.
Thank you. Thank you, Rodrigo. Thanks, Peter. We've got as well another question around standards. Are there any known standards to abide to with regards to the development of software in software-defined vehicles?
Not that I'm aware, but I would say that in terms of what is defined for the automotive industry, I mean, what relates to software-driven systems, you will have to abide to the ISO 26262, which is the which is the standard for functional safety in the automotive industry, and by that is where it is defined the development life cycle applicable to any system inside the car. So I would say that at least from where I stand from, I don't see any standard defined in terms of software-defined vehicles.
Okay, we've got as well a very interesting question. We have seen in a new industry built on top of the end of data privacy. Do you see this also happening in the automotive industry, and who will own the data? So take, for example, the Google's Android Automotive, where Google provides and controls the framework, leaving to the OEMs and tier ones the apps and the hardware abstraction layer. What is your opinion on that, and your positioning regarding the data collected by the connected cars?
Yeah. I think this is a very good question, because this ownership and monetization of user data, this is a huge let's say hope for the traditional OEMs to gain in future revenue streams. And this is also the big danger at the same time, by getting in let's say non-automotive player, aka the tech giants, right? No matter if they are from Silicon Valley or from Shenzhen, in letting those in the vehicle, so that they control the large amounts of data, the platforms that process the data. I think this is a play of the giants at the moment, and the traditional OEMs have fully understood that and want to avoid that this user data is getting in other parties' hands. At the same time, we do see new regulations and new initiatives, like the pan-European Gaia X program, where large data platforms should stay in continental hands and get proper regulations for transparency and privacy. And I do think this whole Gaia X initiative, it's highly underrated at the moment. Yeah, it's a topic for specialists, but it will widely influence the automotive industry, because it will define rules how to store this sensitive user-defined data, and also rules and regulations how to process those and monetize this data. So I think that will be a very interesting topic from now on for the next years.
Right on.
Yeah, thank you, Peter. Maybe we will have just two last questions. It appears that TSMC will have a production plant in Europe, mainly focused on the production of silicon for the automotive sector. Do you think that it will cover the lack of chips for the industry?
This is a good question. Yeah. So I think what we have seen here with the chip crisis. Yeah. So two indicators. As I said, there's a short-term problem of having too less chip capacity for the automotive industry, right? But on a larger scale, we see that there is no let's say highly integrated a small structural manufacturer facility of chips in Europe. Yeah, I said even if they start now, when we talk about the 5, 7, 10 nanometer processes, getting that facility up and running, it's a matter of years and not matter of months, and it will cost several billions of dollars. So this in the short term it will not help much. Yeah? In the longer term, I think it is required from an industry politics point of view that Europe manages it, that these competitive, highly integrated or small structure manufacturing capability is coming to Europe. So either if it's just TSMC or if it's European companies who invest to that. So I think a fab alone will not solve the problem, but what we will see is that the automotive industry is globally getting a better hand on the available production capacity.
Okay, thank you very much.
If I may just add one point, which I believe is extremely relevant on this, which is the fact that the design of chips, the IP cores of chips, okay, with the business around ARM on late last year, Europe took the conscience that they need to have a protective approach towards the IP cores that are developed to be used in systems inside Europe. And so we are seeing and we are watching a movement in the industry trying to identify either open hardware approaches or European-led approaches to secure a way of producing chips with IP cores which the property is based in Europe.
Thank you very much, Rodrigo. Thanks a lot, Peter. We have many questions, and of course, we will get to your question, and due to a lack of time, we will respond to you over an email, of course. Thank you very much. So thank you everyone for attending today's webinar. If you have any other questions, please contact us at our email marketing address. Once you leave today's webinar, you will receive a survey on the presentation, and we would appreciate if you can complete it and provide your feedback. You will also receive a follow-up email with the link to view a recording of today's webinar. On behalf of Altran, part of Capgemini, and our presenters, thank you for joining us today.
Thank you.